My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 647. In this lecture, we will try to understand several equations related to Lstm. Just try to read this is a slide from my previous lecture, that is 646. Just try to recall this. See this network, this is like forget gate, which says how much of the information from previous cell state to how much of the information from previous cell state should retain to the next cell state. That's what this literally does. What is this plus indicates? This says how much information should added after I remember some part of it. Most important thing is you can have skip over connection, isn't it? We have seen this top part. Now let us try to understand this part. It takes two inputs. It takes ht minus 1 xt. It concatenates both of them. There is simple sigmoid layer. Just see, this is sigmoid layer. What is my wf? Wf is bunch of weights, isn't it? Ft, just see what is my ft. Ft is nothing but my ft here is sigmoid of wf. What is this wf? Wf is basically two sets of weights. One set of weights from here. This is one set of weights from here, and another set of weights. Just see, this is one set of weights. You can have one set of weights from here and one set of weights from here. These two set of weights will be concatenated and they are calling it as W. W is basically two set of weights. Here one set of weights, here another set of weights, isn't it? Means one set of weights from ht minus 1 and one set of weights from xt, isn't it? If I concatenate these weights at ht minus 1 and xt, I get wf. It is called forget gate weights. What is this wf? Wf is called forget gate weights, I can say, isn't it? You can concatenate both of them to get wf. Both of them means weights at ht minus 1 and weights at xt. Similarly, you can not only weights at xt minus 1, xt and ht minus 1, not only weights at xt and ht minus 1, you can also concatenate xt and ht minus 1. Just see, you can concatenate xt and ht minus 1. This is my xt, this is my ht minus 1. What is my wf? Wf is weights, it's basically two set of weights. Weights at ht minus 1, weight at xt. That is wf, isn't it? What is my this bf? We are adding bias term. My bf, this is bias term. Your ft is mathematically speaking. What is your ft? Ft is, just see, this ft is, what is mathematically speaking, what it is? Sigma of the, just see, this is my ft. Ft is mathematically speaking sigma of wf. What is this wf? Forget gate weights, the weights that you have here. This weight is concatenated with this weight, isn't it? The weights that you have here, this weight concatenated this weight, that is wf. You concatenate both of them, you get forget gate weight, that is wf. This is called this what is this? This gate is called forget gate. If I speak strictly, what is this? My wf is basically two set of weights. It is just similar to, I can say, this is similar to W transpose X plus B. People used to say this B is bias term, which we discussed long back, isn't it? WF is called forget weight, isn't it? FT is called, what is my FT? FT is called forget value. This entire gate, this gate is called forget gate, isn't it? This entire gate is known as forget gate. Just see this one, we have done with this top connection, we have done with this particular forget gate also, isn't it? This is called forget gate. Just see, this is called, we have done with this connection. With this connection means we completed two parts. Which parts we completed? This part we completed, we also completed this part, isn't it? We already discussed this ft equal to sigma of wf dot ht minus 1 xt. This is plus bf, isn't it? These two parts completed. What is my it? Just see, it is wi into, what is this? This one, wi is weight input to the sigmoid. Just see here, it is sigmoid of, just see, this is my it is sigmoid of wi means what? Weight input to the sigmoid, isn't it? Weight merged at ht minus 1 xt, that is weight merged at ht minus 1 xt, that is wi, and your ht minus 1 and xt, that is this one, plus you are adding some bias. Just you are saying that bias is bi, that is sigmoid of means this is sigmoid of these things, that is my it, isn't it? In similar manner, just see this one, this is called, this particular gate is called input gate, isn't it? This is, the structure tells how much from previous stage should be retain, how much from previous stage should retain or forget, isn't it? This one says how much you add to the previous stage because of this plus operator. Here you have plus operator, how much I can add here, isn't it? Now this is what is your ct tilde? Just if you observe carefully, here I have tan h network layer. Just see tan h, you are, for tan h, what you are writing here, just see ht minus 1 xt, this is ht minus 1 xt, wc is weights, concatenated weights, and you are adding some bc, bias, isn't it? Tan h of, this is tan h of, if you understand, just try to understand, tan h of, this is tan h of what? wc dot this ht minus 1 xt, some bias term. This is essentially ct tilde, isn't it? What is this ct? ct is essentially ft star. What is this? Just see this one is here what you have, here you are getting ft from this portion, from this particular portion. Just see, from this particular portion you are getting ft, from this particular portion you are getting ct minus 1. This is pointwise multiplication, that's what I am writing, ft star ct minus 1 plus this portion I am getting it, and I have also ct tilde here. This is pointwise multiplication, in between what is this? Addition. Therefore here I am writing addition. Just try to understand this. This is so simple, so straightforward. Anybody can understand how this ft is your, how much you forget, that we discussed, how much you should add to the state, that is this plus, how much you can add. Just see, here you have plus, therefore how much you can add, isn't it? Just see, this one is output gate, isn't it? Just see, our OT, this OT is different from our old OT, that one is not same as this one. Here I have OT sigmoid of, just see, w0 dot ht minus 1 xt, some bias. What is my ht? Just see, this is my ht. If you understand this one, this part is ht. Just see, this is my ht. ht is what you are getting, OT. I am writing OT. This is pointwise multiplication, isn't it? What you are getting here, this is tan h is there, tan h, this is ct, tan h of ct. Just see, this is what's happening here. I have tan h function, this is tan h, you are getting ct, therefore tan h of ct you are getting, and here what you are getting, OT. In between what you have, in between you have this pointwise multiplication, just into s, that's what I am writing. This you can Just go through this blog. This blog they explained so nicely. Just one must have some sort of patience so that you can understand. What is this? This is basically says how much from previous cell state should go to the next cell state. That is, this is known as forget gate, this is known as input gate, this is known as output gate. I request all of you, try to understand this slide. What is this? This is forget gate, this is input gate, this is, what is this? This is output gate, isn't it? Just say this repeating module in an LSTM. The input gate says how much the cell state should be modified, isn't it? If you want, you can have skip over connection in this place. In this place, if you want, you can have, if you keep all ones here, if you keep all zeros here, this is skip over connection. Same CT minus 1 will be as same as CT, isn't it? Long term dependencies are possible because you are able to retain cell state. Your long term dependencies is possible. Why? Because you are able to retain cell state. Your CT minus 1 is same as CT. When you say, when you have here ones, and you have here ones, and when you have here zeros, isn't it? Yes, that's what it says. Just it is something like in residual network there is something like identity mapping. You can have something like this skip over connection, isn't it? Even if you go through it, long term dependencies are possible because you are able to retain cell state. Even here also long term dependency is possible. Why? Because your Y3 is directly depend on Xi because of the skip over connections, or I can say because of this identity map. I request all of you to go through this blog and read it once or twice so that you can understand this particular lecture. First time you may feel a little bit confusing, but after one or two, just make one or two revisions so that you can understand. But understanding several equations related to LSTM is very, very important. Thank you very much.